Our project, Deep Learning Gait Recognition, is a pipeline that provides service such as human localization and human gait recognition for hybrid surveillance system like drone surveillance system. Some importance of gait recognition in surveillance system are: it is an advancement in computer vision, in conjunction to the advancement in parallel computing with GPUs for the past decades. Visual-based gait recognition is categorized as behavioral biometric measurement, where any identification and classification of individual can be done in distance without physical interaction. By implementing deep learning network for efficient visual-based gait recognition, it enables automatic indexing of individual action in real time on any video surveillance system. Besides, this also enabled the scaling of public security enforcement, especially in smart cities. Some existing problem that is present on current static or mobile surveillance systems are: human detection and localization is not robust enough for complex backgrounds and environment. For instance, static surveillance system with background subtraction algorithm will certainly not working well when the camera is in motion. For mobile surveillance system, it is difficult for robust detection, as the object perspective is distinct from frame to frame. And some existing solution in action recognition do not feature human localization while doing action recognition in continuous video stream. Therefore, in this project, several developments are made to enable process of human detection, localization and action recognition in a single deep learning pipeline. Plus, the network is capable of processing continuous stream of video. Last but not least, deployment of the pipeline in cloud computing is demonstrated for remote processing. The gait recognition pipeline consists of two major deep learning networks. The first network is responsible for human detection, which is done by using a single-shot multi-box detector. The video streamed in is processed by the human detector for human detection. Next, the second network in the pipeline, that is responsible for human action recognition, consists of an inception convolutional neural network and LSTM layer. The action classification network recognizes action by exploiting the spatial temporal feature of the human in the video. Hence, using exploited spatial temporal feature of the detected human, the gait of the human can be recognized. Here is the detailed process of the gait recognition pipeline. First, detection of human is done using the SSD human detector. Next, the human is cropped in frames for the next process. Using the cropped human feature of 2047 data points are extracted from single cropped human. This array of data points is appended into n number of 2D array, which represents the spatial feature of the human. Next, the 2D array of spatial feature is forwarded into LSTM layer for spatial temporal feature processing. Using generated spatial temporal feature, individual gait can be recognized using several fully connected neural networks. Upon the development of the pipeline is tested on KTH datasets. The pipeline is trained for 5 classes of action: walking, running, boxing, hand waving, and hand clapping. The results show remarkable outcome with high recognition rate. However, the processing rate is not yet in real time, which can be solved with fine-tuning of the pipeline. After testing of the pipeline in test datasets, the pipeline is deployed in actual IP surveillance camera feed. The results of the recognition using unmodified pipeline from previous test are able to produce high detection rate, considering the pipeline only trained with low-resolution datasets in grayscale video. Therefore, by training the pipeline using actual surveillance datasets and fine-tuning, the pipeline recognition capacity can be scaled up tremendously. The gait recognition pipeline can be applied in local network or with cloud computing. In local network application, IP camera and a back-end computer is required. With IP camera, the surveillance video can be streamed wirelessly to the back-end computer. Furthermore, the back-end computer can act as local storage and processing unit for gait recognition. Ultimately, the pipeline is hosted by cloud computing services, such as Google Cloud Platform. Instead of powerful back-end computer, by using neural computing efficient module found in Google Cloud, the performance of gait recognition can be improved. Moreover, a camera is only required to have internet connection to stream the video to the cloud for processing. All the surveillance log will be managed and stored in the cloud. Hence, by using cloud computing, the pipeline also can be scaled by hosting the recognition pipeline as service provider. That's it for our project. Thanks for watching.